Hello everyone, this is SAMARTH JAIN from DTU presenting you ignition delay period in CI engine. Ignition delay is defined as the time from when the fuel injection starts to the onset of combustion. Both physical and chemical processes must take place before a significant fraction of the chemical energy of the injected liquid is released. The physical processes are fuel spray atomization, evaporation, and mixing of fuel vapor with cylinder air. The good atomization requires high fuel injection pressure, small injector hole diameter, optimum fuel viscosity, high cylinder pressure. Rate of vaporization of fuel droplets depends on the droplet diameter, velocity, pressure, and temperature of air. Physical processes are fuel spray atomization, evaporation, and mixture of fuel vapor with cylinder air. Chemical processes similar to that described for autoignition phenomena in premixed fuel air, only more complex and heterogeneous reactions also occur. Factors that influence ignition delay in diesel engine are compression ratio, inlet air temperature, coolant temperature, jacket walker temperature, fuel temperature, intake pressure, air-fuel ratio, and engine size. Now first we will look at compression ratio. The increase in the compression temperature of the air with increase in compression ratio evaluated at the end of the compression stroke is shown in this figure. It is also shown in the same figure that the minimum auto ignition temperature of fuel decreases due to the increased density of the compressed air. This results in a closer contact between the molecule of fuel and oxygen, reducing the time of reaction. The increase in the compression temperature as well as the decrease in the minimum auto ignition temperature decreases the delay period. The question arises is that why do we not use very high compression ratio in CI engines? One of the practical disadvantages of using a very high compression ratio is that the mechanical efficiency tends to decrease due to the increase in weight of the reciprocating parts. The second is engine speed. The delay period could be given either in terms of absolute time in milliseconds or in terms of crank angles. With increase in engine speed, the loss of heat during compression decreases, resulting in rise of both temperature and pressure of the compressed air, thus reducing the delay period in milliseconds. However, the degrees of crank travel, the delay period increases as the engine operates at higher RPM. The fuel pump is geared to the engine and hence the amount of fuel injected during the delay period depends on the crank degrees and not on the absolute time. Hence, at high speeds there will be more fuel present in the cylinder to take part in the second stage of an uncontrolled combustion, resulting in high rate of pressure rise. Outputs. With an increase in engine output, the air-fuel ratio decreases. Operating temperatures increase and hence delay period decreases. The rate of pressure rise is unaffected, but the peak pressure reached may be high. Injection timing. The effect of injection advance on the pressure variation is shown in this figure. The injected quantity of fuel per cycle is constant, as the pressure and temperature at the beginning of the injection are lower for higher ignition advance. The delay period increases with increase in injection advance. The optimum angle for injection advance depends on many factors, but generally it is taken to be 20° BDC. Quality of fuel used. The physical and chemical properties of fuel play a very important role in the delay period. The most important property of fuel which is responsible for chemical delay is the self-ignition temperature. Lower the self-ignition temperature, lower is the delay period. The effect of cetane number on the indicator diagram and the injector timing is shown in this adjacent figure. The delay period for a fuel having Cn is equal to 50 is lowest and pressure rise is almost also smooth. Maximum pressure rise is least as most of the fuel burns during the controlled combustion. Intake temperature. The delay period is reduced either with increased temperature. However, preheating of charge for this purpose is not desirable because it reduces the density of charge and volumetric efficiency and power output. Intake pressure. Increase in intake pressure or supercharging reduces the auto-ignition temperature and hence reduce the delay period. The peak pressure will be higher since the compression pressure will increase with intake pressure. This is the table for the effect of delay period. Thank you and have a nice day.